Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see the problem longest common subsequence. It's a continuation video of the same question, that is longest common subsequence. In that video we talked about the solution of this problem with first with brute force, and then we optimize the solution using dynamic programming memoization technique. Now in this video we will use the tabulation approach. So the one those who have directly landed on this video, I would suggest to please watch that video first. I will paste the link of that video in the description of this video, so that you have clear about the question and the basic recursion and memoization. Then you can jump to this tabulation approach. Here I would suggest you guys to first go and watch those videos to better understand the question and the brute force and memoization, and then come back to this video to watch the tabulation approach. So let's start with the tabulation approach. So as we know, for the tabulation, it means from bottom up approach. So we have to find the solution, optimal solution for smaller subproblem, smaller or smallest subproblem, and using those optimal solutions to find the solutions of larger subproblems. So our base condition was either of the strings, like if the index 1 goes less than 0 or index 2 or index 2 of the string 2 goes less than 0, we return 0. So that was our base condition. So here also if we take example a b c d and a b e d, the base condition will become smallest optimal solution for our tabulation method. That is, for if the index goes less than 0, index 2 goes to 0, means the empty. If suppose this one is s1 string and this is s2 string, and this represents, before a, this represents the empty string for s1 and this represents the empty string for s2. So for empty string of s1, the common subsequence with s2 will be 0, and for the empty string s2, the common subsequence with s1 will be 0, right? So if we say a b s1 and s2 as empty, there is no common subsequence between them, right? So common sequence will be 0. This is our smallest optimal solution. Also in our base condition we saw that. So now we have our dp 0, 0 as 0, dp of 0, 1 as 0, right? Or our dp of 1, 0 is also 0. So we have all our dp's, or the smallest possible optimal solutions defined, right? And then we have to move up from bottom. So we have our bottom conditions ready. These are our bottom conditions: this cell, this cell, this cell, this cell, this cell, this cell. These are the cells, are the bottom conditions. So we'll start with this cell. So it will be dp, because the characters match. So what we will do, 1 plus dp of index 1 minus 1 and index 2 minus 1. So we'll take the diagonal, because if we go left and up, right, we have to decrease the string length of string 1 as well. So if we decrease the index of s1, so we'll go left And if we want to decrease the length index of s2 as well, right, this is string s1 and this is string s2. So if we want to decrease the index, shrink both the strings, so for if we want to shrink s1 or decrease the index of s1, will go left, and for s2 will go up, so it will be diagonal. So what it will be, 0 1 plus the diagonal element. So for this first one, if the characters match, we go diagonal up, right? And if the characters do not match, so let's see the next characters, a and b do not match. So what we can take, the maximum of either shrinking s2. So if we shrink s2, I have to go up, right? I have to go up, so I can take the upper value. I will go up, so I will take 0. Or if I'm shrinking s1, so I have to go left. So if I go left, right, I have to take the left value. So left value is 1 plus 0 equal to 1. So max of 0 comma 1 is 1, right? So it will be max of up comma left value, because up will shrink s2 and left will shrink s1, and that is what we have to do. We have to first shrink s1 and keeping s2 as it is, or keep s1 as it is and shrink s2, right? Decrease the index of s1, keeping s2 as it is, keeping s1 as it is, and increase the index of s2 and take the maximum out of it. So that is what we will get by taking the left and the upward up element. So we'll do this process for further cell size. A and C do not match. What we will take? We'll take the maximum of left and up. That will be 1. A and D do not match. What will take? The left and up. Maximum of left and up. That will be 1. B and A do not match. So the maximum of 0 and 1, 1. B and B match. B and B match. So I will take 1 plus diagonal up. That is 1. So it will be 2. B and C do not match. What I will take? The maximum of left and up. That will be 2. B and D do not match. Maximum of left and up. That is 2. E and A do not match. Maximum of left and up, 1. E and B do not match. What is the maximum of left and up? 2. E and C do not match. What is the maximum of left and up? 2. E and D do not match. What is the maximum of left and up? 2. D and A do not match. What is the maximum of 0 and 1? 1. D and B do not match. What is the maximum of left and up? That is 2. D and C do not match. Maximum is 2. D and D match. D and D match. So what we will do? 1 plus diagonal element here. 1 plus diagonal, because I have to shrink the size of index of s1 and s2 both. So it will be diagonally up. So 1 plus 2 equal to 3. So this will give us the final longest LCS of that both the strings s1 and s2. So dp of n m gives us the LCS of the s1 and s2. So let's see the code part of it. So we initialize NNM with the sizes of text1 and text2, both the strings. We initialize our DP. We perform the for loop for iterating through each cell starting from 1 comma 1, and then if the characters match, we take 1 plus the diagonally up element, else we take the maximum of up and left, and finally we'll return the DP of NM. So let's try to run this solution. So yeah, test cases are passing, so this solution works. See the time complexity of it. If we see the time complexity, we have 2 for loops that are running, so it will be order of n cross m for n for n cross m, right, for n for this loop and m for this loop. For each value of n, we are iterating at post n So for n values, we'll be iterating n cross m, right? And there will be, what will be the space complexity? Space complexity will be order of n cross m, because we are storing in a 2D array. So hope you like this video. If you like this video, please share and subscribe. Thanks for watching.